So let's change the v and w axis to I prime and j prime, and the x and y axes to I and j. So we can say that vector u is equal to u I prime j u j prime, which is equal to I prime dotted with I. Well, we should put these up there. J prime, I prime dotted with j prime dotted with I, j prime dotted with j times u I u j. This allows us now to take the vectors that we had in specific axes and represent them by some index of some sort, some index. Now we can actually sum something up like this. So if we take our first one, ui prime, we can say that ui prime, oh sorry, let me make that just a tad smaller. Ui prime is equal to the sum from n, so the sum over n is equal to 1 to 2 in this case, of n dotted with I. There we go. Oh, I'm sorry, this is a bit wrong. Of I prime dotted with n times u n. We can take this even further and say that ui prime, we can say, let's remove that prime, we can say um is equal to the sum of n is equal to 1 to 2 of the sum of m is equal to 1 to 2 of m dotted with n times u sub n. There's a bit of a step there, but keep with me for a little bit and we'll jump on to the next step. Remember, with vectors, and in this case this will be with matrices, we can do the exact same thing. Seeing as we're doing the dot product, we can change the order in which we multiply them in, or we dot them in. So let's do that here. We'll change the order of summation. This is equal to, and we can do this as well if you remember to ODE, because the LNA really, and not LNA, linear algebra, because the indices and the limits on both summations, the limits on both summations are the same, so we can change the order around. Sum from m is equal to 1 to 2 times the sum from n is equal to 1 to 2 of m dot n u sub n. What does this allow us to do? Well, this actually allows us to make a more accurate definition of what this m dot n is. Now, if we let m dot n equal to a new vector or a new matrix, call it a dot n. Let me erase some of this stuff on the other side, or even move some of this stuff up. Then we can say that u sub m is equal to the summation over n is equal to 1 of a sub n times u sub n. Hard stuff. But now we're done. Let's erase some of this so that we can be able to get there.